Now welcome back to Master Academy of Mathematics. It is the next continuation problem in higher order ordinary differential equation. Let us think about Cauchy Euler differential equation. So any differential equation is of the form x power n d power n plus p1 x power n minus 1 d power n minus 1 plus so on pn of y equal to q is generally said to be Cauchy Euler differential equation. So if such type of model is available of the differential equation that was given by Cauchy and Euler, both are the mathematicians. Now in order to find out the solution of such Cauchy Euler differential equation, I just give you the procedure here. Based on that you can directly find out the solution. So it should be in this particular form where P1, P2 and so on Pn, these are all nothing but some coefficients, and Q is nothing but it is a function of x. Now you are starting with x equal to e power z such that logarithm of x equal to z. Then you are supposing x into d, it is equal to some theta, x square d square, theta theta minus 1, x cube d cube, theta theta minus 1, theta minus 2 and so on, where theta stands for d by dz. Now you are substituting these values in the given differential equation to get of the form f of theta of y equal to q. Here q is nothing but in terms of z variable. Now you find out a complementary function by calculating the auxiliary equation f of m equal to 0. Then you are finding particular integral which is yp equal to 1 divided by f of theta of q. Now you are applying your previous well-known methods based on the function of q. Then you are calculating complete solution. It is yc plus yp. So this is the brief procedure to be available for Cauchy Euler differential equation. Now let us have a problem. Solve x cube dqy by dx cube plus 2x square d square y by dx square plus 2y equal to 10x plus 1 by x. So is it looking like Cauchy Euler differential equation? Only the thing is x cube means it should have compulsory d cube. X square must have d square. So like that it is in the same combination, you can say that it is Cauchy Euler differential equation. So first you write down in the symbolic form. So how to write down the symbolic form? If I am introducing d stands for it is d by dx. So based on that directly I am writing here x cube d cube plus 2x square d square plus 2 of y, that is equal to 10x plus 1 by x. So this is about your given differential equation. Now in order to apply your Cauchy Euler differential equation, let us start with x equal to e power z. This indicates log x equal to z. The next step is you are introducing x into d equal to theta, x square d square equal to theta theta minus 1, and still we have x cube d cube. So you are substituting x cube d cube theta theta minus 1 theta minus 2. Now these values you are substituting in the given equation. So what about this x cube d cube means theta theta minus 1 theta minus 2 plus 2 into x square d square is nothing but theta theta minus 1 plus only constant 2 is there. This is of y, that is equal to 10 into what about the x value? We supposed it as x is e power z. So x is e power z plus 1 by x. That means 1 divided by e power z. That I can write e to the power of minus z. So now you just make the simplification. If I make the multiplication theta square minus theta, it is multiplied by theta minus 2 plus 2 theta square minus 2 theta plus 2 of y equal to 10 e power z plus e power minus z. Again I am making the simplification, direct multiplication here. So it becomes theta cube minus 2 theta square plus 2 theta plus 2 theta square minus 2 theta plus 2 of y. It is 10 e power z plus e power minus z. So on making the simplification, theta cube as it is, minus 2 theta square plus 2 theta square is cancelled. Minus theta square, one more term is there, and plus 2 theta minus 2 theta is cancelled. We have only plus 2. Okay, theta cube minus theta square and plus 2. It is of y, that is equal to 10 e power z plus e power minus z. Now this is looking like some f of theta of y is equal to q model, where f of theta stands for theta cube minus theta square plus 2, and q is nothing but 10 into e power z plus e power minus z. So based on that, you are just calculating the auxiliary equation. What is the auxiliary equation? F of m equal to 0. That means in the place of theta you are substituting m. So that m cube minus m square plus 2 equal to 0. So how many values are there for m? 3 values. So by using your calculator directly, you are getting the answer. M is minus 1 and 1 plus or minus I. So roots real and complex also. So based on this particular roots, you can directly write down YC. So therefore your complementary part YC equal to, how to write down? First you write down the real part, it is C1 e to the power of minus 1 into x, corresponding to the complex roots, plus it becomes C2 cos of, so C2 cos of, the imaginary part coefficient is 1, so 1 into, shall I write x or z? It is not actually x variable because it is converting into z variable, it is z only. C1 cos 1 into z plus C2 sin the imaginary part 1 into z multiplied by e to the power of, so what about real part? 1, so 1 into z. So that is about your YC, or I can write C1 e power minus z plus C2 cos z plus it is C3 sin z. It is of e power z. This is about YC. Now you are calculating YP. So YP means 1 divided by f of theta of q. So 1 divided by, what about f of theta? We calculated theta cube minus theta square plus 2, and q, your right side, 10 e power z plus e power minus z. So now this is 10 constant. I am just separating here. 1 divided by theta cube minus theta square plus 2, it is of e power z, and plus 1 divided by theta cube minus theta square plus 2 e power minus z. So now this is equal to 10. So by applying your previous methods, it is looking like e power ax type. So directly theta is replaced by a value. Will you get 0 here? In order to say whether it is 0 or not, look at this a value. Here a value is nothing but 1. So a value 1 means, is that value present in the roots? No. So since that root is not present, you will not get the 0 value. So directly it is 1 cube minus 1 square plus 2, and this is of e power z, plus coming to that value, here a value is minus 1. If I substitute here, will you get the 0 value? Automatically minus 1 is present in your given roots, so definitely you will get 0. In that case, you write down in terms of factors. So you are writing these factors. It is theta plus 1 and another is theta square minus 2 theta plus 2. These factors can be calculated by, based on your roots we calculated for m. So already one minus 1 is there, so that you are getting theta plus 1. The remaining can be calculated the expression by applying synthetic division. So e power minus z you are just keeping as it is. Now this is equal to 10. So write down here 1 cube minus 1 square. So 1 minus 1, 0. So totally you are getting 1 by 2 e power z plus Now you are substituting that a value in that factor where you are not getting 0. So if I write a value minus 1, here you will get 0 value. Rest of the factor you are just substituting. It is minus 1 whole square minus 2 into minus 1, and here it is plus 2. Since here you are getting a 0 value, as per your principle, the power is nothing but 1. So I can write here it is z divided by power value is 1. So 1 factorial and e to the power of minus z. Now this is 10 into, it becomes 1 by 2 e power z, and plus 1 divided by minus 1 whole square is 1, and it is plus 2, and here we have z e power minus z. Or I am making the simplification individually, 5 e power z, it becomes 4 plus 1 5, it is only 2z e power minus z. So once you get yp, therefore y equal to yc plus yp. So what about yc? c1 e power minus z plus c2 cos z plus c3 sin z, and it is multiplied by e power z plus 5 e power z plus 2z e power minus z. But actually, what is the meaning of e power z value? We started with x equal to e power z value. So that value you are substituting here. C1 e power minus z can be taken as 1 by x, plus it becomes C2 cos of that z value is nothing but log x, plus C3 sin of z value is log x, and totally e power z value, which is nothing but x, plus 5 into e power z is nothing but x, plus 2 into z value becomes log x, and e power minus z value is 1 by x. So that is about your complete solution corresponding to the given differential equation. Now let us have certain exercise problems. X square d square minus xd plus 1 of y equal to 2 log x. Shall I use Cauchy Euler equation for this? So d square coefficient must be x square, d coefficient must be x. If it is a d cube, definitely it should have x cube. So same model, so you apply your method and this is your answer. Okay. Coming to the next problem. X cube d cube plus 3x square d square plus xd plus 8 of y equal to 65 cos of log x. So you apply the same process and you will have certain answer, somewhat lengthy. Better you apply in a systematic model. Coming to the third problem. X square d square minus xd plus 2 of y equal to x log x. Same procedure. And the next one, x square d square plus xd plus 1 of y equal to log x into sin of log x. So this is one more different type of problem on Cauchy Euler differential equation. Better you solve the last one and you text in the description WhatsApp group comment so that I can verify your calculated answer. So with this, your Cauchy Euler differential equation is closed. In the next video session, we directly enter into Legendre differential equation. So have a good day.